link in the community so people can watch
Cool.
more like sessions.
All right. So, okay, I'll be talking about my experience of moving from a traditional continuous deployment pipeline to GitOps with Flux V2. Now, GitOps, we have heard it multiple times. Neha and Shubham covered it. Sangam also covered it. So it is a new, I don't know, should we call it a buzzword? But yeah, it is a new word that people and wondering that what exactly it is. It was the same story for me as well. Like, what the heck it is? So I'll tell you about my production experience of actually operating on GitOps and how we moved away from a traditional continuous delivery pipeline and the tool using Flux. About me, I am co-founder at One2End Consulting. We are into back-end reliability, infrastructure, engineering, and what One2End Consulting is primarily into back-end and site reliability. What we really look and thrive is to actually from shipping code to running things on production with best practices. So you can talk about availability, reliability of the systems that are, of course, these are the words that are thrown, but it takes a lot of time and toll to reach there. So yeah, that's what I do at One2End. Yeah, let's begin. Well, this is a typical deployment pipeline looks like. Everybody wants to, go through the process of having all the neat and the very purest process to actually deploy your code to your environment and infrastructure. Well, now this I found it funny that at the end, if it doesn't matter if it fails or passes, you just go ahead and deploy, right? So yeah. So what we will be doing today is I'll set up a high level of expectation, what it is, an overview of GitOps. We'll compare with a traditional uh, CD pipeline. Use what Flux CD V2 and the toolkit it actually offers. Why we opted choose GitOps and Flux. Will tell my constraint. Maybe it may work or it may not work for your use case. Of course, a demo. DevOps India conference cannot go without a demo. What are the challenges with GitOps? Right. So, what is GitOps? We have heard it multiple times in a day, but I'll repeat it again post lunch. So, GitOps is a term that is actually coined by this company called Weaveworks. They are the primary folks who coined this term GitOps, and also the project Flux came from them. Well, in GitOps, you actually start treating your source of truth as your Git repository. So everything that is there is part of code. Now, infrastructure as code is something that has become a very common practice, that you operations people and operations team actually write their code and push it into a Git repository, and that becomes the de facto source of truth. So everything is actually around that. Declarative provision of manifest. So all our manifest YAMLs for be it Helm or Kubernetes manifest, they are actually or for say example your Terraform code as well is actually declared is in a declarative format. So there are the software agent who are actually responsible for the reconciliation for what is actually running in your on your production or your environment, and what is actually part of your Git repository. These agents are actually responsible to ensure that the state is maintained at any given point of time. There are alerts that you can actually have on the state divergence, that in case if there is any kind of a state divergence that has happened, like, look, I want an 1 plus 1 and you have a 1 plus 2. So we need to go back to 1 plus 1 again. So, it will say that, no, look, you are right now not on 1 plus 1, you are now on 1 plus 2. Changes are all observable in Git history. We can see all the commits and logs can be there, and you can find like who pushed what and what happened. Well, the operations are actually done using pull request or merge request. So somebody in your team can actually have a look, like, look, this code looks fine to me. This is tried and tested. All right, let's merge it to the main branch, right? So I'll start comparing this with a traditional CD pipeline. Now, if you have a look at this, this is the first challenge that I'll throw. That right, you have this is a very simple, very high level diagram. So you have developers who has access to the code repository. They are pushing their code, and then you have your continuous integration pipeline, and which can actually access your code repository, right? And it does all the magic of running the test, linting, validation, and then generates an artifact out of it. Well, that artifact is something can be a Docker image, and that can be pushed to a container registry, right? Now, once that you have that, you also need to actually deploy this. Now, when you need to deploy this, what you really need is some API credentials. So I need an API credentials to actually push to my Kubernetes cluster. Now, the problem here is the moment you start doing this, you need the Kubernetes environment is running somewhere outside, and your CI/CD tool is actually running somewhere. So you are crossing the boundaries, and now actually started to access the Kubernetes cluster from your CI/CD system, right? Now, once you are doing this, what actually happens is that you have to share the credentials. Well, this may be a problem when you are actually working in a very fintech organization, or you are working in where there are strict compliance across cross-boundary credential sharing, right? So that's the challenge. What is the solution to it? Now, if you look at the solution, you said, yeah, look, everything looks okay. What I'll do is, instead of pushing it, I actually pull from it. So previously, the challenge was the push pipeline. The pull pipeline will say, okay, I'll take it from whatever I have actually inside my cluster, and I'll try to sync it with my GitHub repository, okay, for example, and it will actually pull those changes, right? So this is the desired state that you want is actually stored in the Git, and you pull it from there, right? Now, what's the second challenge? So monitoring actually systems of the deployments. Now, what happens is that from your CD system, yes, you can definitely, in a push-based pipeline, you can definitely go ahead and say, well, look, what I'll do, I'll probably just, keep on pushing it, but I really don't know what's the end state. Is it a success? Is it a failure? Probably I may or may not get an alert. I don't know what actually happened. I don't have that visibility. Now I have to go and look into the other system as well, right? Well, there is no denying the fact that you can't do this. Definitely, from a push pipeline, you can do this. You can write up a custom code, but that will be a very tedious job. It's not a very first-class way of handling these things, right? So GitOps actually comes with its own monitoring, and majority of the tools, right? It is as a concept, it is part of it. It differs from a tool to tool, right? And it also supports retries. Retries is something that it caters to that. Okay, in case if it fails one or twice, I'll try it again. Why? The reason could be that there could be a network connection barrier, or services are not reachable. Challenge 3. Now, this is the most relevant challenge that I have faced wherever I have actually worked: cross-environment access. So think about it. Let's say pick Jenkins as your build tool as CI, and your deployment tool CI/CD system. Now, for your CD system to actually access it, it is possible that you'll have to do up a lot of VPC pairing between different environments, and that is a very overhead for the infrastructure and network team. They'll have to keep on saying, oh, okay, I need to connect this environment, that environment to my Jenkins, so that I'm able to actually connect and actually do these deployments, right? So probably your infrastructure and network team is always like, with their screwdrivers, is always like patching things here and there, unless you don't have a very dedicated network and infrastructure team. But if you are working in a small team, it becomes very tedious and problematic. Well, since GitOps is a pull-based pipeline, you don't require no more cross-environment access, right? You don't need that, because everything is actually part of your Git repository. That guy will pull it for you, deploy it, and say, yeah, I'm done. I don't need anything else. Challenge 4 is environment-specific configuration. Now, what happens is that, okay, if you have 3 or 4 environments, you have always sometimes a runtime configuration. Now, these runtime configurations can be some secrets, some endpoint, some database endpoint. Now they can vary per environment. Now, here's the thing. What you can do is that you can actually start making all of these runtime configuration as part of your Git repository, right? Well, other way, you can say that, no, why do I need that? I can actually put it in probably a console KV store, or I can actually store it somewhere in a vault as a secret manager. Sure, you can do that. But now that's again another tool where somebody has to go and populate that, right? So you have to start thinking that if I can actually keep everything in my Git, my state is saved, right? The state maintenance, which probably we heard in the Terraform talk. So that actually is part of the Git repository itself. So you start treating Git repo as configuration as a code, right? And everything is actually part of your Git repository. Well, other benefits, definitely it's a repeatable process, because now everything is part of your Git repository. Anybody in the team can start, actually whoever joins it knows it. Yeah, this is the code that how actually things are running on production. There is nothing that is a surprise to me, or there is a learning curve. That okay, this is the state what we have, this is the state that is actually running. I'll actually just pick it up and I'll be able to learn it easily. The chances of reducing human error. Why? Because now all your runtime configuration and everything is part of your Git repository. It ensures that everything is actually, the chances to actually alterations will be minimal. Not saying that it will be completely gone, but it will be minimal. And of course, Git is a tool which is widely used by tech teams and engineering teams, so they can actually operate on this existing knowledge. So they know it what needs to be done, right? Uh, why actually we decided to move towards a GitOps? So we were actually a small team of DevOps practitioners. Now what happens is that when you have a very small team of DevOps practitioners, or they are always one or the other thing. They are either plumbing something, either they are on call. And what used to happen was developers were always actually blogged on the DevOps team and wanted to deploy new images. They want to say like, okay, can you just deploy this? And they were shipping multiple times in a day. So think about it, that a DevOps team was started to become a blocker on it. Well, one way was to actually teach the devs to actually deploy by themselves, but not a lot of developers are in for it. They're saying like, look, I'm a developer, I have a lot of deliverables to do at my plate. I don't want to get into this. You take care of this part, right? Sure. So how do you do this? He said, okay, all right. How about this? If I actually if I set up something like a GitOps process, will you be more than happy to just operate on the Git knowledge, where we can also contribute? So it's a good way of a collaboration for both the teams as well. So yeah, fine, let's do that. So you have the PR based model structure, that okay, this is, I want to deploy this Docker image tag. I want to just change the tag, push it to create a new branch, push it for a PR, raise a PR, ask team members like, can you review it for me? And then boom, everything is done. It gets deployed automatically. Last point was very thing interesting is security team had, as I said, that concerns of accessing Kubernetes clusters from outside, and they wanted like, because what we were working was actually in a fintech domain. They said like, look, okay, if you are using GitOps, I think probably we are more happy you using this, because then we can actually make not a Kubernetes cluster accessible from outside anymore. If you have to deploy it, you don't need multiple jump box and whatnot. You can say like, okay, this is configured. Probably I can actually pull it from my controllers, will pull it from the Git repository, right? Let's move towards Flux CD. If you have any questions, do post it on that, and I'll try to address it at the end of the session. So Flux CD v2. So if think of it like GitOps is actually an interface. So Flux CD is a tool that actually implements it. Flux CD is one of the tools, by the way. Sangam already discussed that what all tools there are based on pull and push based pipeline, but I'll be discussing right now Flux CD because that is my experience as well of using it. So Flux CD actually offers something called as a GitOps toolkit. What they really believe in. V2 actually came out recently. I think it's been 5, 6, or 8 months at the beginning of this year, and earlier they were using Flux V1, which was more of a monolith, and everything was actually part of it. Now they've broken down into microservices where there are certain controllers responsible for doing individual things, and that we will be discussing in the upcoming slides. Now, GitOps toolkit is composable API for CD, so you can actually keep on building upon your CD system as well as in when you like, because they provide you the SDKs and everything. You can actually do that, right? It internally uses Kubernetes controller runtime libraries, and you can actually work with Kubernetes events and create CRDs of your own, right? Besides what they actually have to offer, they are also responsible for reconciliation of the objects that you really want, because they are part of the Git repository in itself, right? Uh, what are the toolkit components? So there are 5 components majorly. There are, of course, in image automation, there are split, but we'll take at a very high level for the 5 components, what exactly they are doing. So first is the source controller. So source controller is like source registration, authentication, and resource fetching. So what they do is, what they do is actually, take up, probably you create up a GitHub token, they will fetch it for you, they'll actually fetch the resources and then sync it to your Kubernetes cluster. So these source controller can be anything like a Git repository or Helm repository or an S3 back packets, right? And they are primarily for the reconciliation of the source code. Customized controller. So Flux heavily uses customize to actually organize their directory structure. We'll actually look at it into one of the slides as well as a demo, that they have a customized controller where you identify resources like, look, these resources I really want to be synced and actually put to my Kubernetes cluster and deploy, right? So they generate actually these manifests with the customize, and they keep a watch on them. They also take care of the garbage collection. So in case if there are some resources which are not required, you can ask them to actually prune it, so they will actually clean it up for you. So if you remove some of the resources from the Git repository, they can actually, it will start reflecting to your Kubernetes clusters as well, right? You can definitely define specific pipelines that you want to run a backend first, and then you want to run a front end. And then definitely it also reports your cluster state changes to the notification controller. That's another controller part of the toolkit as well. So Helm controller. So this is something that I really kind of liked it, because earlier what we were, before moving to GitOps, we were actually using Helm charts, and we didn't want to rewrite. We wanted to reuse our existing Helm charts, because it gives us the ability to do up a loose coupling. Now what's the benefit of it? The benefit is that we can actually use GitOps for a dev and QA environment. For a production environment, we will still deploy it manually, because for whatever reason, because we don't want to actually touch our production environment and get a surprise. So we said that let's us operate it. Because Flux was supporting Helms, that was like really good thing for that I personally like. It actually watches Helm chart object for any kind of a revision changes. It does an automated remediations that has to be done for the Helm charts. You can define the sequence of your Helm charts, that which chart should go first and which chart should go later. All of this was actually is taken care by the Helm control. It also reports Helm release status to the notification controller, right? So basically, notification controller is actually is the controller that deals with all of the incoming and the outgoing events that are required. So what it will do, it will create any kind of an event based pipeline. It will keep on getting all these events and capture them. So and all the other controllers keep on sending these events to notification controller. As I've said that Flux support mostly a pull based pipeline, but with notification controller you can create up a push-based pipeline as well. How? So what you can do is on you can have a set up a GitHub webhook which can actually point towards a notification controller, which can take it up and actually start up your CI/CD process as well. So if you want up somewhere an event-driven thing from outside of your Kubernetes ecosystem, you can do that with the help of notification controller. So you can connect it with any ingress, and that guy can actually take up that event, listen to it, and then start up a complete trigger a complete pipeline as well. And based on the events, this notification controller is also able to send alerts to different channels. So we will be actually covering this in our demo, right? Image automation controller, well, this guy is responsible for scanning the image repositories. So if there are any kind of image updates that has happened, this will take care of what is actually coming in. So and it's also able to update the YAML files with new Docker tags. Of course, you can provide up a regular expression that this is the regex that I would want to take care of it, and it can take care of that. So it listens to your Docker registry as well, that what new Docker images have been pushed. You can definitely commit the changes to your and it can not you it will actually push the changes for you to the Git repository as well. So if I have to look into this is the actual diagram. This is from Fluxy docs. These are the this is the Kubernetes API. This is the source controller from GitHub, GitLab, Helm charts. And then source controller and Helm controller listens to it and says that, yeah, these are the new resources, and it will actually create it in different environments. Customized controller will look for any kind of a different resources that you have created and listen to the talk to the direct Kubernetes API. Right. Now, question is, why did you actually landed up using choosing Flux? Well, so this was a very specific use case and reason for you choosing Flux. The reason was, you can use existing Helm charts. So we can actually use Flux. We were able to use, as I discussed, able to use our existing Helm charts, and it gives us a loose coupling, and we just extended the GitOps based solution on top of it. Right. Argo is another solution to it, but it was a very overwhelming component. Like we never knew that we would ever require to go to a multi-tenant kind of a system and whatnot, and have that kind of a granular control what Argo provides. It's like Argo is like the big brother of Flux. One really good part was supports SOPs. So what is SOPs? SOPs is secure ops, and what happens is that we were actually pushing all our secrets into the Git repository. Now you can say that pushing secrets into the Git repository is not cool, right? That's not a good practice. Well, what we were doing, I think Sangam also discussed this whole SOPs part for the security at GitOps level. So we were actually encrypting it using a asymmetric key pair, public and private key, and providing to our controllers like, okay, this is our private key. Can you actually decrypt it and apply these secrets onto the Kubernetes cluster? One part is the lightweight and less maintenance, very CLI based thing, very lightweight. You don't really have a lot of buttons to click, so you can never get confused. You need to just read the documentation. Flux supports monitoring with Prometheus, so that was one part that you can have a monitoring because it has a endpoint. You consume that scraping endpoint and actually put a Grafana on top of it, and then on top of it you can have integrated with a PagerDuty for an L1, L2 support in case if something goes bad. Because now you have an observability of what actually is happening onto your Flux series system as well. I would like to now actually look at the code structure directed, how it was. So this, if you look at it, that we had a deployment repository where all the infrastructure as code was lying. So what we had was like we had a skate as GitOps dev. So dev had service 1 and service 2, right? It has all the config map, customization, release, and secrets. These are our Helm charts. So Helm charts were the standard Helm charts that we were consuming it, and these were the Helm values. Now if you look here, these Helm values are specific to an environment. for develop environment, for production environment, and for QA environment. So everything was actually part of the one single Git repository. But we had, because Flux supports, listening to a particular subpath, we were able to separate it out on or at Git level itself and Git hierarchy itself. So yeah, this is how the complete pipeline actually looks like. So there are those developers who are pushing code to the application repository, right? Uh, and then you have your Jenkins pipeline. This is a very basic naive test build, uh, you know, and pushing the artifact, generating artifact, and pushing to a Docker registry. Now, what you have here is that you have your DevOps practitioners who are changing the Docker tags and config maps, and then pushing the changes to a deployment repository. Now, deployment repository is where the actual, the GitOps is implemented. So now you have this Kubernetes cluster. You have different controllers who are doing a lot of magic, and what they do is they actually pull the changes from this Git repository and then send the alerts, and then you give a notification. So yeah, this is how a pipeline actually looks like. So time for a demo. Am I still audible? I'm still still around. Sangam, can you just send me an act?
Yeah, yes.
Hello.
Yeah.
Yeah. Okay. All right.
So do you want to take questions or direct demo?
Can I take the demo and then probably take up questions at the end?
Yeah, yeah, sure. Sure.
All right. Okay. Fine. So I am running on a kind cluster on my local system for now, and what I will do is probably I have my Git token, so I'll bootstrap my cluster probably here. Yeah. So I'll bootstrap. I've said that these are my components that I need to install. This is the path on which I would like to install. This is the branch, and yeah. If you look at it, the Flux system has actually started to come up. These are the controllers that have started to kick in. All right, now this is done. If you look at it, we have this. What we will do is look at our Git repository. There is nothing right now, and the controllers actually just push the Flux system configuration here. So what we will do is, I'll just remove my older one. Okay, there we go. Now we have this Flux system states and everything. Now we actually, let's do one thing. What we'll try to do is actually just configure our Flux system. Now I have created up already some setup. So first of all, let's actually go to GitOps Flux system GOTK sync. So this has the configuration about, let's say, even the Flux system configuration is part of your Git repository to actually reconcile. So I'll do some changes that I don't really want to do prune it, for example. So I said, yeah, okay, fine, right? That's one change. I'll apply another change as well. So I have my notification.yaml. As I said that we will apply some notification to actually start sending some alerts. Let's hope that actually works. We have the Slack channel, for example. So I'll say that, yeah, notification.yaml and say like Flux system, so that we can start receiving alerts as such. Now, if you look at it, the notification controller alert has been initialized here. Let's hope the endpoint is there and valid. Yeah. Okay. So this is how it looks like. This is the notification. I said that this is my channel, this is my address, and I want to watch on all of these CRDs. Right. Now let me do one thing. Let's actually push Git. So I said, okay, Git add GitOps Flux system GOTK sync. YAML. The commit, I say that, okay, reduce the sync interval to 1 minute. Right? I say git push origin main. Yeah. Now, meanwhile, we have this. Let's hope it starts synchronizing in a while. Meanwhile, what we're doing, we will actually start creating up a directory structure, what we showed in this slide. So I'll do is actually create as I'll say helm chart sentence values here. All right. So I would like to show this the tree here. So what we have, so we have this GitOps for the dev environment. I just got a message. Now, what it did was it actually fetched the changes. It said that, okay, all of these changes are configured, and it identified in itself. Yeah. Now, next is what? Next is to, this is our tree structure. Now, what we can do is let's actually start uh, adding services to it for which we want to be deployed on our Kubernetes cluster. Right? So if we go here, there is GitOps, there is dev. What I will do is I'll have already created up a directory structure, GitOps dev service, right? And then we have customize these values. Just bear with me. I'll explain what exactly it is. So let's have customization.yaml. So customization.yaml, I'm saying that please have a look at this service one as a resource and identify, keep a watch on this. I would want you to actually deploy this, right? Now, if we go to this service one, what do we have? We have this customization.yaml. So customization.yaml is saying that, okay, this is a customization thing. This is a config map generator. This is like a one config map which has all our helm values are actually part of it. I'll show you in a while what exactly it will have. And if I look at it, it says that, yeah, these are my helm values which we will be using just for the dev environment. And if you look at the release.yaml, so release.yaml has that, okay, this is my helm release, this is my helm chart, this is the source is my Git repository, name is Flux system, and in sync interval is 1 minute. And the values are from, this config map service1.yaml that we actually just created in the customization.yaml. Right now, what we will do is we have it. Now what we can try to do is actually just deploy this to us cluster. Git status, I'll say git add, GitOps, add everything here, git add and charts. Git commit add service one. I push my changes, that's done. Right. Let's actually wait. Update completed. Let's go here. Should have something in a moment. Yeah, let's wait. Meanwhile, what we will do is we will start preparing for an SOPs based of a demo. Okay, so Helm installation has started. If you look at it, this is running, right? And yeah, this is what we deployed, service 1.0.1 here. So this is a success. Now, what about some secrets? We discussed about SOPs part. So let's actually try to look at that as well. So this is a secret. Just keep a watch on here. What I will do is I'll configure up an SOPs at mine. So I'll go here, GitOps dev here. I'll create one file probably called as sops.yaml. I'll just paste it from here. I will. Now, if I look at this .sops.yaml, what basically is actually a PGP key, which is actually part of my local system. Now, SOP support, you can use asymmetric keys. It can support Azure's KMS and Vault, so it can integrate well with that. So have a look at that project, Mozilla SOPs. Now, what I'll do is I'll actually, copy my secret that I have already created. So I'll say that, okay, this secret.yaml to service one. Let's have a look. Secret. Now, this cannot be pushed, right? This cannot be pushed. How do you do that? So what we will do is we'll actually encrypt this. Now, to encrypt this, what we will do, we will say that, okay, socks encrypt in place service one secret.yaml. Now, if I look at my secret.yaml again, this is actually encrypted. Completely is actually encrypted. Now I have encrypted it locally. What I really need to do is actually tell my Kubernetes, Flux system, like okay, look, we have a PGP key ready, so why not? You should be aware about it. So how do I make it aware about it? I have some commands which are ready here, and I'll say that, okay, just create a. This is part of the configuration, by the way. Here, the secret has been created, and I said, okay, Flux customization to blah blah blah. This is done. So if I look at it, edit customization Flux system, SOPs now, Flux system knows, okay, this is the provider is SOPs, and this is the secret reference that I need to look for decryption of the keys, right? Now this is done. What we can do is it is git add service one secret.yaml. Oh, before that, I'll have to tell my resource release.yaml, like, look, not release.yaml, sorry, customization.yaml, that you should also keep a watch on secret.yaml, which is part of your directory. I said, yeah, okay. So what we do now, we add service one customization.yaml and git add service one secret.yaml. Git status, we have two files, let's say git commit add secret for service one, git push origin main. Done. If you look at our git repository, I'm right now, by the way, this model needs to be on a PR based thing. I'm right now pushing it directly. It should not be, it's not encouraged. If you look at it, there are help charts, GitOps dev, service one. I have the secret, and this secret is actually encrypted. If you look in the Git repository. Okay, now let's just wait. If you look at it, this secret has been created by itself. So everything is part of your Git repo, right? Now this is, all of this is done. What we really need to do is say, okay, I want to actually upgrade from 0.1 to 0.2. That's what developers were doing. They said, okay, I want to go to 0.2. Here is the thing. So I'll say, okay, git add this, git commit -m upgrade service to 0.2. Git push origin main, and we should start seeing this should update in a moment, right? Yeah. Meanwhile, this is happening. So if you look at the Slack, there are some changes that has been done. Please apply your changes to the latest version. Let's see. If you look at it, the old version has been terminated, and now the new version has been applied here. Yeah. So 0.2, and I'll say that, okay, I want to roll it back. I say, okay. Revert. I'll say revert. So upgrade service 2 to 0.2. I can say going back to 0.1. With this git push origin main. Yeah. Now if you look at it, it will identify it. It will, because it's your rollbacks are also as an append only log. You just keep on incrementing. You can just do up a revert as and when you want. So let's started, and yep, we are now back to 0.1. Right. So this was the demo part. I'll actually come back again to my slides. So, what are the challenges that I actually faced with GitOps? Well, Git is not actually designed for programmatic updates. Well, what happens is that if there is a Jenkins which you want that even these changes that are done by the developers or DevOps team push for the dev config that we change, the helm values, that has to be also there. You can do it, but you need to take up a lot of hit and tries, because there's a possibility that if or more multiple developers are pushing to the same Git repository, you may get conflicts and whatnot. So you have to it's not very seamless. You'll have to work towards actually making your automatic part of it to capture all those hit and tries, that in case there are conflicts, merge failures or auto conflicts, whatnot, you need to handle that. That is a bit tricky and hairy. Maintaining multiple repository has maintenance overheads. So think about it, that if you are multiple developers who are working towards multiple repository, then creating Chinese wall becomes a problem. SOPs makes PR reviews inconvenient. Definitely, like you can't really see what exactly it is, right? So you probably will have to get the key and review it. I wish that if Git has this whole plugin to enable like some kind of an SOP. I wish. So that was really inconvenient. But again, that was a trade-off that we said, like, fine, we can actually live with it as long as our secrets are secure. Uh, these are the resources. We wrote a blog on this, so definitely you can actually have a look. Of course, GitOps.tech for documentation. Flux series has really great documentation. And also, if you want to look more about GitOps, this is a really good book. I found it actually starts from a traditional push-based pipeline to actually moving towards a pull-based pipeline. Yeah, that is about me, and we are actually hiring and looking for reliability and DevOps practitioners and backend engineers. So if you are interested, feel free to drop a message. I'm more than happy to talk. Thank you. I can probably, Sangam, now take up some questions.
Yeah, so this time we have like question from one of a colleague who work at Accurix, and he's
Yep.
here in the backend. So he has like 3-4 questions.
Sure.
Have a check.
So, so
Hey
how
Sam,
does Flux
thanks for
compare
that.
to?
Yes,
Hey,
I
hi,
go ahead.
Sama.
Hey.
Yeah. So I think I can read it. So there are 3 questions. How does Flux compare to Argo? Well, as I said, that Argo is like the big brother. There are a lot of other capabilities that it provides, a multi-tenancy. Of course, Flux has also started to do that, but again, it's a third-party project. Not sure how integrating it in. Flagger also Argo supports control of AB and Canary and whatnot. They were primarily doing it. But Flux has recently started with the whole Flagger part in the project, right? So they are trying to catch it up there. In terms of if you are like a smaller team and not a if it is a lightweight system, then definitely Flux makes more sense. Argo gives you a low granular control, like what, okay, do you want to deploy this? You want to go ahead and not. These are things that Argo provides. If that's my
Yeah,
opinion.
because I tried with Argo, but like based on the time I had, it was getting difficult to get that working to the way I wanted.
Yeah,
Especially,
yeah.
I was not having access to a state. Like that was my next question. Like, how do you manage state? Like, is there any way to expose the state in Flux? Some to a system like Prometheus or some kind of an API.
So is it to expose the application state? When you say the application state, basically understanding that is it successfully running or not?
Successfully deployed or running, what is the current state, what.
Yeah. So Flux, as I see, actually very valid question. It, in case if there is it is failing for some or the other reason, it will not be able to tell you that. It will only say that, okay, if your Helm chart had some certain issues or Flux itself was not able to deploy that, then it will say, okay, it has failed, and then it will notify it on whatever notification channel that you have taken.
Yeah.
As such.
Because we are harmonizing around Prometheus and Grafana, like at work.
Yeah.
So I want to, like, we are also like deploying custom metrics for our applications. So I want to see
Right.
if Flux can do that, right?
No, Flux probably its role ends up at the deployment part, and what actually, I mean, of course, it can tell you that your deployment was successful or not, or in such. But in case if there are any kind of an application level error, probably it will not. It will not be. I mean, I don't know as of now,
Yeah,
to my knowledge.
I'm talking about the Flux level. Like, what is a, let's say it has 10 applications. What is the state of the different applications, and can I roll back to the previous version through an API, right? Not go into Flux.
Through and yeah, I mean, you will probably have to write up some kind of a role controller, maybe not directly. I think it can actually detect it. Yeah.
Okay. And the other question I had was like with Argo, the basic requirement is like your Helm charts and the value should be in the same repo. Like value should be at the root of the Helm repos, right?
Right.
So that kind of was a no-go. But does Flux have any similar like?
No, you can actually define up any path you. It will to, let me just share my screen. Maybe I can just help to answer this. Yeah. So can you see my screen, right?
Yeah, I can see.
Yeah. So if you look at it, these are my Helm values here in devconfig.yaml. This is for service one. If I go here and service one, open GitOps dev Flux system, not Flux system, service one, sorry. And then you have this, not really, sorry. Yeah. If you look at this file, I have identified this is where my file is. So I can define it at any path as I like and as I want, whatever the tree structure I want to maintain as such.
Okay, but can it also pull the Helm charts from another repo? Let's say
from another
I only have
it supports that. Yes, it can. It can.
Okay. Okay.
And you have to just identify that. Yeah.
Yeah.
Oh, cool.
That was a good talk. So.
Thank you. Thanks, Eva.
Yeah, I enjoyed a lot. I don't know much about Flux, but I learned something today. I learned a few of the new
Glad you
GitOps tool like XLA. I know how to encrypt and all these things. I never play around Helm chats. But this is a great question from Shiva also. And there is another thing which I am very fascinated with. A lot of conversation is going around. One of creator of the Rancher and K3S, he wrote a library we send the read a data from Kubernetes controller, right? So you can do that with directly read and write in Git. So he wrote a kind of controller. So there is a lot of tool and so there is a lot of Git GitOps like Autopilot is there, Argo Autopilot which help manage your
Verf is also there. I think some.
Yeah, that one also there. So there is so many GitOps tool.
With the whole GitOps toolkit, you can do that. Yeah.
Yeah, and by the way, if those who not using GitOps, not wanna use GitOps, they can use Spinnaker. There are other alternatives also, so they can do same kind of thing. But it's a great demo and totally demo oriented, and we talk lot about GitOps now in this conference. So let's move on to the some of the serverless
Too
talk.
much GitOps.
So we have So we have Arif. He will be sharing around serverless. Over to you, Arif.